example of when we have three variable system. That means we have three equations this time. Each of these three equations have three letters, x, y, and z. Notice that my z's, I'm going to try to write them that have this little slash in it, because sometimes my z's look like 2's. So that's just a way. Remember to be very careful when you're writing this. We don't want our z's to become 2's and we get something wrong. So what we need to do ultimately is we need to work with just two equations at first, and we need to make it, instead of three variables, we need to get it down to just two. It doesn't truly matter which equations you use. I'm going to use the top two first, and I'm just going to rewrite them over here. 4x plus 2y plus 3z equals 12. I just rewrote it. Haven't done any math yet. 2x minus 3y plus 5z equals negative 7. So what we need to do is get one of these letters to eliminate. So go back to your elimination practice and think about that. So I'm noticing that my x's are pretty close to each other. If this was a negative 4, my x's would go away. So what I'm going to do is times that equation by a negative 2, because negative 2 times 2 is negative 4x. Negative 2 times negative 3 is a positive 6y. Negative 2 times 5 is a negative 10z. And negative 2 times negative 7 is a positive 14. And I'm going to cross this guy out so that I don't look at him. So now 4x plus negative 4x is nothing. That was our goal, is to get one of our letters to go away. In this example, we're getting our x to go away. 2y plus 6y is 8y. 3z plus negative 10z is minus 7z. And 12 plus 14 is 26 equals. Now I'm going to star this equation, because this was what we need to have to do this problem. We have an equation now with just a y and a z. We got rid of the x. Now we need to do this one more time. But we can't use the top two equations. You could use either the first and third equation or the second and third equation. It doesn't matter. All that matters is, since we got the x to go away over here, whatever we do next, the x must go away. So just to, because I've noticed that I can, I'm just going to look at these two equations right here. We must get these x's to go away, because we got the x's to go away over here. So if I turn this number into a negative 6, they would go away. So I can times by a negative 3 to everything in this second equation, and it will become, then eventually my x's will go away. So negative 3 times 2x is negative 6x. Negative 3 times negative 3 is a positive 9y. Negative 3 times 5 is a negative 15z. And negative 3 times negative 7 is 21. Now I'm going to cover this up so that I'm not confused. What we've just done is we've taken the second and third equation and we've rewritten them this way. Our goal was to get the x's to go away, and that's what's going to happen. We're going to add them together. These have eliminated. Negative 1y plus 9y is 8y. 4 plus negative 15z is negative 11z. And negative 3 plus 21 is 18. So now I have this equation that we did first. It's got a y and a z in it. We now have this equation that has a y and a z in it. Now we're going to take these two equations and we're going to stack them. So I'm going to rewrite it right here. Now they're stacked, and now it's going to be like an old-fashioned elimination problem. But right now my y's do not go away because they're both positive. So if you times one of your equations by -1, they will go away. So -1 times 8 is -8y. -1 times -11 is +11z. And -1 times 18 is -18. Now your y's will eliminate. -7 plus 11 is 4z. 26 plus -18 is 8. We divide by 4, and z, 8 divided by 4 is 2. So what we now know is that z is equal to the number 2. So now we need to figure out what our other two numbers are. Now that we found that z equals 2, and remember that this was the system of equations that we used to find that, like we were doing earlier this week, we would plug in 2 for z and find out what y is. Now we can use either one of these equations. I'm just going to use this bottom one because it makes my life a little bit easier. So I'm going to take -8y plus 11, but instead of z, I'm going to plug in a 2 because I just found z to be 2. And it equals -18. -8y plus 22 equals -18. We'll subtract the 22, and we will get -8y equals -40. Divide by -8, and we get y as an answer of 5. Okay, so now that we know that the z is 2 and the y is 5, what we're going to do is go back up to the original problem and steal one of these equations. I'm going to just recopy the first one, 4x plus 2y plus 3z equals 12. And I'm going to rewrite it and plug in what we know. We don't know what x is yet, so we're going to leave x to be the letter x. Plus 2, but instead of y, I'm going to plug in 5 because y is 5. Plus 3, and instead of z, I'm going to plug in 2 because we found z to be 2. And we're going to solve this equation for x. So 4x plus 10 plus 6 equals 12. Now the 10 and the 6 are like terms. So 4x plus 16 equals 12. We want the x by itself, so I'm going to subtract 16 from both sides. 4x equals 12 minus 16 is -4, and therefore x is equal to -4. So our answer, we put them in alphabetical order. So parentheses -4, comma 5, comma 2 will be our final answer.